our world and beyond. Space, in partnership with the European Space Agency.
After 5 months docked to the International Space Station, the European Space Agency's first automated transport vehicle, Jules Verne, separated from the ISS and set off on its final voyage.
The ATV re-entry has been accurately calculated with statistical means in order to define a ground track of the debris, which does not include populated areas on ground.
Guided by mission control on Earth, the ATV gradually lost altitude in a succession of descending orbits.
The re-entry trajectory has been observed by an aircraft equipped with special optical systems in order to determine the size and the distribution of the debris generated by the spacecraft breakup.
Friction heat of 800 degrees provoked the controlled disintegration of the vehicle and its cargo of waste 120 kilometres above the Pacific Ocean.
3, 2, 1, top. Allumage Vulcain, allumage des
The Jules Verne is 10 metres long and 4.5 metres in diameter. Launched by Ariane 5 from Kourou on March the 9th, the ATV delivered 6 tonnes of cargo to the ISS. The supplies included reboost and refuelling propellants, water, oxygen and more than a tonne of dry cargo. The carrier then took away 2.5 tonnes of waste. The ATV automatically docked onto the ISS using laser guidance and carried out 4 manoeuvres to reboost the ISS to a higher orbital altitude. The Jules Verne mission has opened the way to other possibilities, says ESA's human spaceflight director.
Now we know how to deal with elements on board the space station. We have a reliable launcher, so Ariane 5. We have demonstrated with ATV that we are able to dock safely to the station. Now what we need is to develop the last segment of this chain, which is the capability to safely bring back first samples and then humans to the Earth. And then also being able to, let's say, to operate this chain in the proper way.
This is how developers see the ATV of the future. Like the Jules Verne, the craft would also transport cargo, dock onto the ISS and reboost the station to a higher altitude. But instead of being programmed to break up on re-entry, the ATV evolution will bring samples from experiments carried out on the ISS back to Earth, a task currently carried out by the American Space Shuttle or Russian Progress supply crafts. At ESTEC, the European Space Research and Technology Centre in the Netherlands, Mario Caporici explains how the ATV is set to evolve.
The projects we are considering are essentially based on a reuse of the service module of the ATV and the replacement of the integrated cargo carrier with a re-entry capsule.
Tests have already been carried out to see how to deal with the problems caused by the high temperatures resulting from air friction during atmospheric re-entry. In October 1998, the Ariane 5 launcher carried the ARD, the Atmospheric Re-entry Demonstrator, up to an altitude of 200 kilometres. The test capsule reached an altitude of 800 kilometres before ditching in the Pacific. The ARD may not yet be fully operational, but the test results are promising.
The thermal protection system has worked very well. The capsule has very little sign from the atmospheric re-entry in the high temperature heat flux that has encountered. Here you see 3 types of thermal protection system. This one, which is for the higher flux, is initially very dark brown, and this is where the highest thermal flux occurs at re-entry. On the side, which is not exposed or is less exposed to heat, you have a lighter type of thermal protection system.
The lighter protection panels are very thin and made of cork. If the re-entry manoeuvres had not been so precise, they would have burned up. Solving the heat flux problem opens up exciting new horizons.
The first element will be a cargo download system. We hope to be able to launch it in 2015 to the station, and after that we will, let's say, work on the crewed version in order to have European citizens flying in an autonomous way by 2020.
Let's imagine 2020, an Ariane 5 launcher is transporting a capsule carrying 4 astronauts. An ATV version Evolution 2. It's a project already being worked on by European engineers like these at EADS Astrium in Les Mureaux near Paris.
The second stage for us will be vehicles that carry a crew, and for that we'll need to develop new technologies. The main one is an escape system, a system that will get the crew out of the launcher if there's a problem during takeoff. That's something we have never done in Europe, but we'll have to master if we want to develop a manned transport system like this.
The moments just before takeoff and takeoff itself are always very risky. If something unexpected happens, the safety of the capsule and its crew needs to be guaranteed.
Say you had to eject on the launch pad. The rocket hasn't taken off yet, but you have to get away from it because there's a risk of explosion. You'd have to go to a high enough altitude for the parachute, like those on Soyuz or Apollo, to be able to open.
Once Ariane is in acceleration phase, its boosters cannot be extinguished. The crew capsule would need to pull away from it very quickly.
The whole idea of an ejection system is to be able to get far enough away very quickly. You'd need to be 300 meters away from the launcher 3 seconds after ejecting, so as to be out of danger if there's a risk of the launcher exploding.
Good luck, Krista.
Europe has its own corps of astronauts who have taken part in numerous research and exploration missions. All they lack is their own European spacecraft.
I believe that human spaceflight and exploration is the future of our society. We need a long-term program done in international cooperation, able to bring us in a new era, able to provide us new capabilities, new developments, innovation in our society. Altogether, we have to focus on human spaceflight and exploration in the next coming years if we want Europe growing and growing in the future.
The ATV is evolving fast. It may not go as far as the moon, but it's tracing a path that is expanding Europe's frontiers in space.